Correlation and covariance in Python. Welcome! In this lesson, we will explore two key concepts for analyzing how variables move together: correlation and covariance. You will learn the basics, see real-world data examples, and get tips for using these tools in your own projects. Let us dive in. Running the cell now. What does correlation mean? Correlation shows how closely related two sets of numbers are. If two things go up or down together, the correlation is strong. If one goes up and the other goes down, it is negative. Correlation values range from -1, meaning always move opposite, to +1, meaning always move together. 0 means there is no clear link. Running the cell now. Let us set up our tools. We need warnings off so error messages do not distract us. We are telling Python to ignore warnings. Warnings are sometimes shown when there might be problems, but now we want a clean output. Now we are bringing in pandas for working with data, and matplotlib for making plots. Pandas helps us handle data tables. Matplotlib lets us draw charts, like lines and bars. Running the cell now. Try running this cell to set up these helpful tools. Let us get some real data to work with. Flights are great for time series because the months line up. Watch as we load a table of airline passenger numbers from the web. We will scan the first few rows so we see what the data looks like. This is a comment line just explaining what comes next. We type in the web address where the data file lives. Now we read that into pandas using read_CSV. This puts the airline data in the data variable. We print out how big the data is, the number of rows and columns. We show the first 5 rows using head. This is a good way to check if it loaded correctly. Running the cell now. Practice, try changing the URL to any regular CSV file online and see what happens. It is easier to notice patterns with a picture. Let us draw these values to look for trends with our eyes. This is just a comment. We set the size of the picture to make it wider. We draw a line for passengers over each month. We label the horizontal axis as month. We label the vertical axis as number of passengers. We add a title to explain what the chart shows. We rotate the month names to make them easier to read. We add a key to explain the line. We adjust the layout so things do not overlap. We finally show the plot to see the results. Running the cell now. Try looking for bumps or patterns in a line. Can you see any patterns by just looking? What is covariance? Covariance is a number that tells us if two sets of values move together and by how much. Unlike correlation, covariance can be any size, including big positive or negative values. Covariance tells us direction, but not scale. Running the cell now. To understand covariance, let us make our own numbers. These lists can stand for simple test scores in two subjects. We put them in a pandas table and ask for the covariance. We start with a comment, just to explain. Here are some made-up math test scores. And here are science scores for the same people. We make a pandas table with 2 columns, one for each subject. We print the table so we can see all the rows. Now we say we want the covariance matrix. This table tells us how math and science scores move together. The number high or low shows strength and direction. Running the cell now. Try making your own 2 lists with a pattern you like. Do you get positive or negative covariance? Let us try the same data for correlation. This gives us a range that is easier to compare. This is a comment line. We print a label so we know what's next. We ask pandas for the correlation. A value near 1 means a strong relationship, while 0 means very weak or none. Running the cell now. Think, if you doubled the scores, would the correlation change? Try it. Why do we standardize data for correlation? Covariance changes if you use bigger numbers, but correlation always fits between -1 and +1. This makes correlation easier to compare between different problems. Running the cell now. Let us see what happens if we make one column 10 times bigger. Covariance will change, but correlation stays the same. We are making a new version of math scores that is 10 times as large. We look at covariance for these new numbers, and also print the correlation to compare. Running the cell now. Notice, only covariance changed its size. Correlation did not. Now let us see if the number of passengers goes up over time. We compare passengers with the month number straight across. This is a helper comment. We measure the relationship between number of passengers and time. We use a series of numbers for months. We print the correlation with 2 decimal places for easy reading. Running the cell now. Try, change the order of months to reverse and see what happens to the correlation. Let us look at totals by year and see how they move from one year to the next. Are busy years followed by even busier years? We pull just the year from the month string and make it an integer. Then we sum how many passengers there were for each year. This creates a new table with totals per year. We print yearly totals so we see them. Now we print a label for what comes next. We use Cov to ask how much each year's total moves with the previous year. Cov tells us if there is a strong up or down trend. Running the cell now. Try, add a column for average passengers per month in each year, and compare years that way. Often in real data, some values will not be there. Let us set the first 2 passenger numbers to be missing and see how pandas acts. We mark this as just a comment. We make a copy to keep the real data safe. We set the very first number to nothing, to act like a missing value. We also remove the next number. Now we ask, does pandas handle missing numbers? We check correlation and see if it gives a number or not. Running the cell now. Try changing different rows to none and see if the result is always the same. If data is missing, we can either fill the hole or throw out those rows. Let us compare both ways for correlation. We start by asking in the comment, how should we fix missing data? Option 1, fill missing numbers with their overall average, so we do not lose any row. We compute the correlation after filling. Option 2, remove all rows with missing values, so only complete ones remain. We compute the correlation again with data that has no holes. Running the cell now. Which option changes the answer more in your runs? Now it is your turn to explore. Type in 2 lists of numbers and see how much they move together. We show a comment to explain the plan. We ask you to enter your first list, with numbers separated by commas. We ask for your second list in the same way. We turn your words into numbers for list 1, making sure to remove spaces. The same for list 2. We show the covariance, which will tell us how the 2 lists change together. We show the correlation, which is easier to compare. Running the cell now. Try making lists with values that always go up together. What value do you get for correlation? In larger tables, you can ask pandas for all column correlations at once. Let us try this with our original data. Here is a helpful comment. We print correlations for every column pair all at once. Running the cell now. What would happen if you added more columns with new information? Sometimes pictures show relationships best. When points are lined up, correlation is strong. We add a comment to explain. We make a scatter plot, which helps us see pairs clearly. We label the horizontal axis for math. We label the vertical axis for science. We add a title to explain the chart. Lastly, we display our scatter plot. Running the cell now. Try changing the math scores and see how the dots move. There is also a fast way using NumPy for lists. This works well for small pairs. This is a comment for a handy shortcut. We bring in NumPy, which can work on arrays of numbers. The core function from NumPy gives the correlation matrix. Running the cell now. Try using NumPy on two lists from before and check if it matches pandas. Now for a mini project. We will look at sales of shampoo over several months. Let us plot how sales change over time. This is a comment to mark a new project. We fetch the shampoo sales table from a CSV URL. We read the data and save it in the shampoo variable. We rename columns for easier use. We make sure all the sales numbers are true decimals, not text. We print the first few rows to see what we have. We plot sales with time on the x-axis. We title the chart Shampoo Sales Over Time. We label the month axis. We label the sales axis. Show what the chart looks like. Running the cell now. Try picking another small CSV with numbers and plot a line chart. Can sales and travel numbers move together? We check if the trend for airline passengers matches shampoo sales. This is a comment for what is next. We measure the correlation between the first rows of passenger and shampoo sales, since the lengths must match. We print the correlation and show it rounded for easy reading. Running the cell now. Now think of two things you would expect to have a high or low correlation in your life. Common mistakes and troubleshooting. Double-check your data for missing or text values instead of numbers. Make sure your data lists or columns line up and have the same length. Use dropner or fillner to handle any missing values before getting correlation. Running the cell now. Extra tips. For big datasets, try core on the whole table for quick exploration. Plots like scatter or line charts help you spot outliers and patterns quickly. For deep analysis, combine correlation with time shifting or differencing. Running the cell now. Here is a challenge. Can you spot where higher numbers in one list match lower in the other? We show this challenge with a comment. We make a list that goes down from 10 to 2. This list goes up from 1 to 9. We print the correlation and look for a negative number, meaning they move opposite. Running the cell now. Try making your own two lists where one gets bigger as the other gets smaller. Recap: what did we learn? Correlation and covariance show how two things move together. Correlation is scale-free, covariance is not. Real-world data often needs cleaning before analysis. Plots help make relationships clear. Try your own data next. Running the cell now. Thanks for learning. If you enjoyed this lesson, like and subscribe to our YouTube for more hands-on Python. Keep exploring and let us know what you build next. Running the cell now. Practice: try teaching a friend about correlation. Can you come up with your own example? And do not forget to subscribe to the YouTube channel for more lessons.